Hi, I'm Iain and welcome to the Northland Workshop. If there's one thing that is universal across all woodworking shops is no matter how big it is, there's never enough storage space. So in this two-part series, we're going to build this workshop countertop, and it serves many functions. It's a place that I can put long boards as I cut them on the radial arm saw. If you have a miter saw instead of a radial arm saw, you can put the miter saw at the end of it and use it as the support system as well. It also has a sliding stop, so that way I can make repetitive cuts that are exactly the same length time after time. Also, it has a whole bunch of drawers, whether they're 4-inch tall drawers for things like cordless drills, or deeper drawers for big power tools. There's a lot of storage space in this one area. The other nice thing is with the drawers, the tools stay dust free. In the first episode of this series, we're going to build the countertop and the cabinets. We're going to build heavy duty drawers with full extension drawer slides that can handle all the tools you could ever put in them. In the second episode, we're going to put the false fronts on the drawers. We're going to put this door and slide out tray in to house the mortiser. We will also build an adjustable stop. This is for the radial arm saw. If you have a miter saw, it'll work for the miter saw as well. And finally, something that every workshop needs, a place to put your offcuts with this little rollout scrap bin. So I hope you stick around and learn something while we build this very useful shop counter. Trying to wrestle an entire piece of plywood through a table saw can be very difficult, and it can be very dangerous. The easiest and safest way I found to handle this sort of operation is actually to start breaking it down using nothing more than a circular saw and the simple circular saw guide. Now this is nothing fancy, it's just an old piece of 1/2-inch plywood with a 1x2 glued and screwed to it, and I jointed the 1x2 so that way it's a perfectly straight edge. That way, when I ride my saw on this, it will give me a perfectly straight line. I made this piece of plywood extra wide originally, and the first cut I made with it actually cut it to the exact width of the base of my saw. So that way now, when I lay out the marks, I butt the edge of this guide right up to it, and it automatically gives me the offset from the blade to the straight edge that I'm looking for. My table saw might max out at a mere 24 inches of rip capacity, but this trusty old radial arm saw will give me 32 inches of rip capacity. So that's what I'm going to use to cut the sides of this cabinet down to 28 inches wide. These cabinets are held together with cross members that are all 33 and 5/8 of an inch long. So I need a way to reliably cut a whole bunch of them without measuring every single one. So to do that, I've set the radial arm saw back up into cross-cutting mode, and I've slid the fence over. And what that lets me do is attach a stop block to it. You'll notice that the stop block doesn't go all the way down to the table, and there's a reason for that. That way, if I get sawdust scooting along the end of the workpiece, it can just pass under the stop block and it's not going to affect the length of cut. If I had it all the way down to the surface, any sawdust that got pushed along would actually jam in the bottom of it and I wouldn't get a consistent length cut. As you can see, there is a lot of cross members in this project and they all need to be joined to the sides of the cabinets. Because of that, I need a joint that is both fast and strong. And to do that, I'm going to turn to the cabinet maker's best friend, the pocket hole joint. As you can see, it's a series of angled screw holes that, when used with these special screws, give you a really strong joint, and it's a joint you don't have to wait for the glue to set up because the screws will hold it in place while the glue dries. Now, to make these angled screw pockets, I'm going to use this special jig right over here. There are many different pocket hole jigs on the market today, but they all essentially do the same thing. They have a mechanism for clamping a piece of wood up against an angled drill guide that you use this special step bit in. It's got a 3/8 diameter drill bit to drill the pocket that hides the screw head, and it has an 1/8 inch pilot drill to drill the hole for the screw shank. And when you use it in conjunction with the angled drill guide and the depth stop, you get a perfect pocket hole every single time. I drop the piece of wood in and I clamp it, and I can go ahead and drill the pocket holes. Assembly is coming along pretty well. All I do is put a little bit of glue on the end of the cross members, and then I get them lined up where they're supposed to go. Because I'm working by myself, I have to find ways to try and hold this in place, and I found at my local home center this interesting little clamp that actually goes in one of the pocket holes, and it holds it tight to the other piece. That lets it stay in place long enough for me to get the other end screwed together. I've got the stacked dado head set up in the radial arm saw, and I'm in the process of cutting half lap joints on the 2x4s that will become the framework for the top. And I've got a stop block set up so that way I can make repeated half laps and they will all come out exactly the same. So I've spread glue on both sides of the half lap joint. Now what I can do is bring it together and put a clamp on it. Check it for square. Now I'm just going to secure it with a couple 1¼ inch drywall screws until the glue dries. covering the 2x4 frame with a piece of 1/2-inch plywood, and that's just going to get attached with some 1¼ inch drywall screws. Even 1/2-inch plywood is pretty expensive, so to protect it, I'm covering it with a piece of 1/4 inch hardboard. Hardboard is really cheap, so in the future, if this gets all dinged up, it won't be too bad to just replace the hardboard. Because I want this thing to be easily removable, I'm just going to be attaching it with a couple drywall screws in the corners. So anytime you try to measure for something, there's a chance that it might not be quite accurate. So the best thing to do is don't measure at all. I've butted up this piece of maple up against the wall, and I put a little tick mark on it where the corner is. Now the other thing I want to do, because it's very easy to get mixed up and to miter it in the wrong direction, and then the piece is no good, I like to just go and put a mark in the direction the miter's supposed to go in. That way, I remember it needs to go that way, not that way. I tipped it to 45 degrees so that way we can cut the miters on the trim. I've laid it out where it's supposed to be from the mark I made earlier, making sure the angle is going in the right direction. Now all we have to do is make the cut. Just gluing the miter joint together isn't super strong because it's just end grain to end grain. The best way to do it is with some sort of reinforcement. That way it stands a better chance of not opening up over time. And in this case, the way I'm going to reinforce it is with this little biscuit. This is a number 0 biscuit, and as you can see, it fits in here perfectly. The way I'm going to cut it is with a biscuit joiner, and this biscuit joiner I've got set so that way it will fit the 45-degree angle just like that. And what I'll do is line up the little pencil line with the red line on the biscuit joiner and make the cut. And just like that, we have the slot for the biscuit. Now I can go ahead and butt the piece of trim up to the wall, make it so it's flush with the top of the bench. And at this end, I'm just going to use this little piece of plywood to make sure it's even, and I can go ahead and nail it in with some 1.5-inch finish nails. And a little bit of glue on the miter, I can go ahead and put this together. Nail it in place. The factory edge on this maple is razor sharp, so I'm just chamfering it with a chamfering bit in my router. I'm using a 3/4 inch wide straight cutting bit to cut a dado in the top of this workbench for this aluminum T-track that just so happens to be 3/4 of an inch wide. One thing you want to keep in mind when trying to route or cut tempered cardboard is to make sure you use carbide cutters. It will absolutely destroy high-speed steel. So just be aware of that. The other thing is, you can see I'm taking multiple light passes because it is a 3/4 inch wide bit. It's trying to remove a lot of material at one time, and I don't want to stress the bit or the router too much. Now you can really start to see how much of a help this workbench is when trying to cut long pieces of wood. These are very big drawers with heavy tools in them, so I've decided to use a full 1/2 inch thick piece of plywood for a bottom. So I've set up the dado head in my table saw to cut a dado for the 1/2 inch plywood. It's time to talk about drawer jointery and how are we going to attach the drawer fronts to the drawer sides. And there's tons of different ways to do it. But for these drawers, I need a way that is both fast and strong. So I've decided to go with pocket screws. As you can see, I've drilled 4 pocket holes in the front of the drawer, and then the screws are going to get driven in to the side of the drawer. So that way, when the false front is applied, you're not going to see any fasteners. You might be able to tell that these are slightly smaller pocket holes than normal. That's because this is 1/2 inch plywood. If you plan on making a lot of projects using pocket holes in materials thinner than 3/4 of an inch, it's not a bad idea to see if the maker of your pocket hole jig makes a drill guide that uses a smaller bit. In this case, the manufacturer of my pocket hole jig, this is their standard drill guide that comes with it. This drills a 3/8 diameter pocket. They also sell one that drills a 1/4 inch diameter pocket. This drill guide is perfect for 5/8 and 1/2 inch thick wood. Along with the smaller drill guide, you're going to need smaller screws. This is a standard pocket hole screw with a washer head. That washer head ends up being roughly 3/8 of an inch in diameter. That's too big to fit in the 1/4 inch pocket made by that small drill guide. To use that, you need to have a pan head screw. As you can see, it's a little bit smaller than the standard one, and this is what we'll be using to construct the drawers. This micro drill guide goes right in the jig, just like the regular one does, and I line it up with the 1/2 inch mark on the side, because that's what the plywood is. Tighten it down, hook up the dust collection, and I'm good to go. First thing I want to do when assembling these drawers is to put a bead of glue in the dado in the front of the drawer. These drawers are made 100% out of plywood, so changes in humidity aren't going to be a problem. Now I want to take the drawer bottom and get it started in the dado. And I want to roughly center it in the sides. If it's not perfectly centered, that's okay. It'll center itself once we put the drawer sides on. Now we can go ahead and put the first side on. Again, I want to put some glue in the dado. And I want to put a little bit of glue along this front edge where it's going to contact the front. Now I can put it together. I sometimes hear complaints of the pocket hole screws shifting the workpiece a little bit because they're at an angle. When you drive them in, they tend to pull back a little bit. But what I've found cures that is enough clamping pressure. What I like to do is clamp right next to where that pocket is. And then you got to remember, these are short screws in thin material. Take your time when driving it in. You don't want to strip these out. Perfect. Now I can drop the back into place. The back also gets fastened in place with pocket hole screws. The drawer bottom gets attached to the drawer back using 5 1.25" drywall screws. I'm using a couple pieces of scrap wood as props to keep the drawer slide in place while I drive some screws in. The manufacturer says on the cabinet half of the drawer slides to use the horizontal slots. Then again, once everything's lined up the way you like it, drive the screws into the little holes to lock it in place. Now it's time to install the drawer half of the drawer slide, and I've drawn a center line on the drawer, and I'm going to use that, centering it in the holes to line up the drawer slide. The manufacturer says to start out with, I want to put a screw in the vertical slot on this drawer slide. I'll just snug that down a little bit. Then once I double check to make sure it truly is lined up the way I want, they tell me to use these little holes to lock it in place. To preserve as much of the usable space in this short drawer as possible, I decided not to do a full 1/2 inch wide dado. Instead, I did a 1/4 inch wide dado, and I rabbited the drawer bottom, so that way I still get the full 1/2 inch thick bottom in the middle, so that way it won't sag, and I gained a 1/4 inch of space in the drawer. This starts over at the table saw cutting this dado. Instead of taking the time to set up the stacked dado head cutter, I've decided to just make multiple passes with the standard saw blade. Assembling the small drawers is a lot like assembling the big drawer. Really the only difference is now the bottom is rabbited And instead of 4 pocket hole screws per side, these ones only get 3. In the next episode, we're going to be building the drawer fronts, the door, pull-out tray, the rolling scrap bin, and the stop block for the radial arm saw. So I hope you join me next time right here on the Northland Workshop.